Welcome to the Rtview autocorrelation display tutorial. Rtview offers an easy-to-use autocorrelation function display. This display allows to view up to 4 autocorrelations simultaneously. To add a channel to ACR display, simply activate it in the Global Control panel. To change the y-axis scale and offset, behave like changing y-axis scale and offset in time diagram. For changing the x-axis properties, use the XDV and XPOS button and behave like an FFT diagram. For more information about the autocorrelation display, see Rtview software documentation. Welcome to the Auto Trigger tutorial for Rtview. Rtview offers an auto trigger function as well as free configurable trigger functions. This tutorial will explain the use of the auto trigger functionality in Rtview. To use the auto trigger, tap on the TRG button and choose Auto. The trigger will be armed after this and listens on the channel defined by TSRC. You can change the trigger source by tapping on the TSRC button and choosing between the listed channels. The trigger will be released when the signal passes the automatically computed threshold with fitting slope. You can alter the slope by tapping on the SLP button and choosing from the appearing list. The last configurable parameter for auto trigger is the trigger position. You can change it by tapping TPOS and scroll to the desired offset. Tap and hold to apply the changes. When the trigger is active, all views will only be updated if an trigger event occurs. The single button enables an single shot trigger functionality. When the trigger got released once, it only gets armed again when you tap on the single or run button again. Tapping on the single button will start another single shot trigger. Tapping on the run button will cause continuous triggering. For information about manual triggering, watch Rtview manual trigger tutorial or look up in the manual. Welcome to the Rtview cross-correlation display tutorial. Rtview is able to calculate the cross-correlation of two signals. To do so, choose the channels you want to calculate by using the X channel and Y channel buttons. If you want to scale the y-axis, use the YDIV and OFF buttons. To change the x-axis properties, use the XDV and XPOS buttons. To alter between the cursor modes, use the Cursor button. To learn more about cross-correlation display, see Rtview software documentation. Welcome to the Rtview coherence display tutorial. To calculate the coherence function of two signals, choose the channels for the calculation by using the buttons X channel and Y channel. When the channels were chosen and FFT averaging is active, the coherence function appears. To change the applied window function, use the WND button. To change the scale of the x-axis, use the XDV button. For shifting the 0 point of the x-axis, use the XPOS button. For further information about the coherence function, see Rtview software documentation. Welcome to the cursor tutorial for Rtview. To create a new cursor, tap on the position you want it to appear. To move the cursor, tap on the corresponding cursor flag, and hold while moving the cursor. If you have set more than one cursor, an additional info window appears with information about the difference values of the first two cursors that were set. To move this info window, behave like moving cursors. You can alter between an RMS and an peak presentation of the difference by tapping on the info window and switching between the two options. To remove an existing cursor, tap on its info flag and choose Delete from the appearing context menu. When you accidentally tapped an info flag, just choose Cancel to leave the context menu without any changes. To automatically set a cursor to instant minimum or maximum of a specified channel, tap on the corresponding info flag and choose min or max. A second context menu appears which lets you choose between all active channels. The cursor will be set to the instant min or max of the channel defined here. If you want to set cursors automatically to the maximum of all active channels and keep them updated, tap on the cursor button and choose Auto Max. This basic cursor functionality is implemented in all diagram types. Further information about specialized cursor functions can be found in the corresponding tutorial or in the manual. Welcome to the Rtview Digital Multimeter Display tutorial. The Digital Multimeter Display, short DMM, offers a numerical display. This display shows the result of the calculation, applied to the selected channels. To select channels for view, use the Global Channel Selector. For switching between the calculation functions, use the Calc button. Choose between one for instant values, without calculations. Mean for the averaged signal value in the time period defined by the T button value. RMS for the root mean square value for the defined time period. Min or max for the minimum or maximum signal value in the last time period. To alter the time period length, tap on T and choose between the appearing constants. In difference to other displays, the DMM update cycle is independent from the first view time domain buffer size. For more information, see Rtview software documentation. Welcome to the fast Fourier transform diagram tutorial for Rtview. Rtview offers a widely configurable FFT diagram. You can alter the number of points, the averaging and overlap. Moreover, you can choose the window function, switch the magnitude scaling and calculation mode. To change the number of calculation points, tap on the PTS button and scroll to the desired number of points. Tap and hold to confirm. To alter the averaging and overlap, behave like changing the number of calculation points and use the average and OVL buttons. The average button offers an auto mode which calculates the maximum number of repetitions that fit in the time domain buffer. You can see the actual frequency domain buffer size, in time display as transparent box at the axis of the time display. If the frequency domain buffer exceeds the time domain buffer, the automatic time frequency domain buffer survey routine will intervene. For information about the behavior of this routine, see Rtview buffer management tutorial or look up in the Rtview software documentation. When you've set up the FFT size, the number of repetitions and the overlap, the FFT is ready to run. Now you can change the wide division and offset of each represented channel, like already known from time domain diagram. You also can use the auto scale function in both modes. If you want to change the scaling of the x-axis, use the XDV button and scroll to the desired value. Confirm with tap and hold. By tapping on the XPOS button, you can shift the 0 point of the x-axis. To change the applied window function, tap on WND button and pick one from the appearing list. The calculation function can be altered by tapping the Calc button and choosing between None, Integration, and Double Integration. To modify the amplitude representation, tap on the AMPL button and choose between the appearing modes. For changing the averaging mode, behave like changing the amplitude representation. To learn more about the benefits of the different amplitude and averaging modes, see FFT chapter in the Rtview software documentation. For more detailed information about the FFT function, see Rtview software documentation. Welcome to the first steps tutorial for Rtview. We will start with the functionality of the time display. To activate or inactivate channels for view, tap on the corresponding button on the channel selector. If you want to change the amplitude scale of the signal, you can change it automatically. Tap on the Auto SCL button and choose Same Y-axis to scale all channels with the same physical unit to the same scale. Or tap on the Auto SCL button and choose All channels to scale all channels to optimum scale. To manually change the Y-axis scale, tap YDIV and scroll to the desired scaling factor. When you've chosen the scaling factor, tap and hold on the context menu. To change the channel offset, behave like manually choosing the amplitude scale. Tap on Off and choose the offset value. The time scale also can be changed like changing manually the amplitude scale. Just tap on XDIV and scroll to the desired time scale. If you have 2 or more channels active, you can adjust the amplitude scale, the offset and the coupling for each channel. To switch between the channel-dependent controls, tap and hold the channel you want to see the controls for at the channel selector. When the channel is selected, the surrounding of the channel-dependent controls will turn to the channel color. Now you can change the properties of the just selected channel. To change to 2 view mode, just tap the Views button to toggle the modes. When you are in 2 view mode, you have to select which view will be influenced by the controls. You can choose which view you want to adjust by tap on the Y-axis of the view. For further information, see following tutorials or look up in the Rtview software documentation. Welcome to the Rtview frequency response function display tutorial. With Rtview you can easily estimate frequency response functions with aid of the FRF display. To select which channels should be used for the FRF estimation, use the X channel and Y channel buttons. Note, the X channel will be interpreted as output and Y channel as input channel. When 2 channels are defined, the FRF estimation appears in magnitude and phase. To alter the Y division of the magnitude representation, use the YDIV button below the X channel button. To change the offset of the magnitude representation, use the Off button below the X channel button. To change the Y division and offset of the phase representation, use the buttons below Y channel. In order to achieve best results at all conditions, Rtview has implemented the 3 FRF estimation functions H0, H1, and H2. Alter the estimation function by tapping Calc and choosing between the appearing modes. Use H1 for best results with respect to output noise. Use H2 for best results with respect to input noise. The buttons WND, AMPL, XDV, and XPOS serve the same functions as in FFT diagram and are used similar. For more information about the FRF function, see Rtview software documentation. Welcome to the manual trigger tutorial for Rtview. This tutorial shows the usage of the manual trigger functionality in Rtview. We assume you've seen the Rtview auto trigger tutorial previously. To use the manual trigger, tap on the TRG button and choose level. After this, choose a channel the trigger should listen to. Now you can set the threshold, slope, and trigger position. First we will set the trigger level. To do so, tap on the TLVL button and scroll to the desired trigger threshold. The actual threshold is shown as dotted line in the view. To change the trigger position, use the TPOS button to scroll to the desired offset and confirm by tap and hold. To alter the slope, use the SLP button. You can choose between rising, falling and window slope. When using the window slope, you have to define a window size and the window offset. You can change the window size by tapping TWin and scrolling to the desired value. To change the offset of the trigger window, use the TLVL button, like setting the threshold for rising or falling slope. The single shot function is also usable in manual trigger mode. Tap on single to run a single shot. Tap on Run to restart continuous triggering after a single shot. For more information about the use of the manual trigger, look up in the software documentation of Rtview. Welcome to the Rtview logarithmic reference tutorial. Rtview gives the opportunity to define an own reference value for logarithmic calculations. This value is called P0 in the program and appears at numerous places. To change its value, tap on the Properties button and choose P0 log y-axis. Make use of the appearing display keyboard to define the P0 value. Tap the OK button to confirm. Now all calculations which make use of the P0 value will change their results. For more information, see Rtview software documentation. Welcome to the power spectrum density diagram tutorial for Rtview. The PSD diagram is based on the FFT diagram and uses quite similar. For this reason we strongly recommend to see FFT diagram tutorial previously. The usage of the PSD diagram differs at 2 points from the usage of the FFT diagram. First, the PSD diagram has an additional button DSPL which allows you altering between power spectrum display mode and power density spectrum display mode. Second, the AMPL button has different scaling capabilities than the AMPL button in FFT diagram. There is no peak scale option, but 2 more for logarithmic scaling. The entire rest can be used exactly like in the FFT function. For more information about the power spectrum density display, see Rtview software documentation. Welcome to the Rtview sound diagram tutorial. Rtview sound diagram display offers a standard conform octave analysis with variable bandwidth, variable low and high cutoff, as well as standard integration times slow, fast and impulse. Moreover, there is implemented an overall level calculation, a numerical channel level calculation and an equivalent continuous sound pressure level calculation, as well as standard weighting functions A, C and linear. Due to the standard conform time continuous filtering in octave analysis, the sound display will be updated continuously without dependence from other buffers. To select channels for view, use the global channel selector. To change the amplitude scaling, use the YDIV button. To change the amplitude offset, use the off button. For the configuration of the octave analysis, use the LF, HF, BW, WGHT, and time buttons. The low cut frequency is selectable by the LF button, the high cut by the HF button. To alter the octave analysis bandwidth, use the BW button. If you want to apply a weighting function, use the WGHT button. For switching between the different integration times, use the time button. With the DSPL button, the drawing mode is selectable. The sum of all levels over all frequency bands is represented as last group of bars in the octave diagram. It's labeled OASPL. The labeling is due to the main purpose of this display, sound measurements. OASPL means overall sound pressure level, but you can use this diagram with any kind of signals, not only audio. Due to the main purpose, sound, the default logarithmic reference value, P0, is 0.00002. For other purposes, change the logarithmic reference value like in Rtview logarithmic reference tutorial. To view the numerical OASPL values, tap on the L button. For monitoring and surveillance purposes, Rtview sound diagram has implemented an equivalent continuous sound pressure level calculation function. To use this function, you have to activate it by tapping the LEQ button, and defining a measurement time using the MES-T button. When a measurement time is defined, you can start the measurement by tapping on Start button. For pausing the measurement in actual state, use the Pause button. To continue the paused measurement, tap on the pause button again. To stop the measurement, use the stop button. For more information, see Rtview software documentation. Welcome to the Rtview spectrogram diagram tutorial. Rtview offers an spectrogram diagram to view the frequency spectrum of signals over a time axis. To activate channels for view, use the global channel selector. In spectrogram diagram, short SPC diagram, the time domain is represented on the x-axis, the frequency domain on the y-axis, and the magnitude is indicated by the coloring. For changing the amplitude scale and so the coloring, use the IDIV and I-OFF buttons. Note, all channels use the same scale here. All scaling actions have to be done with the channel-dependent controls of channel 1. You can see the actual magnitude color assignment right beside the SPC diagram. To change the frequency scale, use the FDIV button. To shift the 0 point of the frequency axis, use the FPOS button. As known from the FFT and PSD diagram, you can alter the applied window function with WND button. And change the amplitude scaling mode with the AMPL button. For more information about SPC diagram, see Rtview software documentation. Welcome to the Rtview storage tutorial. Rtview offers 4 memory slots, where you can save the actual program configuration, so that it can be restored afterwards. To save a configuration, tap on the Properties button and choose Save. A context menu appears where you can choose which slot should be used for storage. After selecting the memory slot, name the configuration by using the display keyboard. When you're ready typing the configuration name, tap on the OK button. Now the configuration is stored, and you can restore it after changes. To restore configurations, tap on the Properties button and choose Load. Choose the configuration you want to load from the appearing context menu. The saved configuration should be restored now. For more information about the storage function in Rtview, see Rtview software documentation. Welcome to the Rtview zooming tutorial. Rtview offers a pull-up frame-like zooming function. To use this function, tap in the diagram you want to zoom in, and hold while pulling up the zooming frame. You can resize the frame by pulling on its sides. To move the frame, tap in its center and hold while moving. To apply the zooming frame, short tap on it. When zooming is active, the button XPD appears in the upper right corner of the zoomed view. Tapping on it will switch back to the unzoomed view. If you have accidentally pulled up a zooming frame, simply close it by tapping aside it. This zooming function is implemented in all Rtview displays except SPC, SND, and DMM, and will also work with 2 separate views. For more information about zooming in Rtview, see Rtview software documentation.